Hi everybody and welcome again to Campbell's Math Corner. So today we're going to be looking at this CXC past paper question on bearings. Now this particular question was taken from the 2014 May-June exam. So let's go straight into it. Alright, so it says the diagram below, not drawn to scale, shows the positions of three ports P, Q and R. So that's P, Q and R. Q is 80 kilometers from P. R is 100 kilometers on a bearing of 066 degrees. So R is 100 kilometers from Q on a bearing of 066 degrees. Now it's important that we know exactly where to put this 66 degrees. Now because I said from Q, and remember we said the keyword is always from, that tells us where to leave from, we know that we should always start with our north line. And from the north line we measure in a clockwise direction, so it must be the angle formed here. So that's where the 66 degrees will be. Now they also said that angle PQR, that's this angle here, is 54 degrees. So the first question says to calculate the bearing of P from Q. Now by just looking, realize that the bearing of P from Q, again from an outline, measure in a clockwise direction. So the angle that we are looking for is all of this, which is the 66 degrees and the 54 degrees combined. So therefore, the bearing of P from Q is going to be equal to 66 degrees plus 54 degrees equals 120 degrees. Alright, so that's that. Now they said to calculate the distance PR correct to two decimal places. So remember now, given a particular triangle, what we want to do is ask ourselves a few questions. Now, is this triangle a right angle triangle? Well, no, it's not. So therefore means that we should either be thinking about the cosine rule or the sine rule. Now, do we know a side and its opposite angle? We know two sides, but we don't know the angles that are opposite to these two sides. And we have this one angle here, which is 54 degrees, but no side. But that's the side that we want to find. Seeing that we don't know a side and its opposite angle, it means that we're going to be using the cosine rule to find the side, PR. So using the cosine rule, we know that PR squared is going to be equal to this side square plus this side square. So it's 100 squared plus 80 squared minus 2 times 100 times 80 times cos, and the angle between these two sides is 54. Now having plugged that in your calculators, and again please ensure that your calculators are in degree. So PR squared is going to be equal to 6,995.44, and then to find PR we find the square root of that, and that is going to be equal to 83.64. They ask for the answer to correct the two decimal places, hence 83.64 kilometers. So PR is here. So that's 5 marks completed. So let's go for the additional 3 marks. For the measure of angle QPR, so they want this angle here at P. So now we know a side and its opposite angle. It means that we can now go ahead and use the sine rule. Now using the sine rule, sine P, which is the angle, over the side that is opposite from the angle, which is 100, is equal to sine 54 over the side that is opposite from it, which is 83.64. Now to get sine P by itself means we'll have to multiply both sides by 100. So sine P is going to be equal to 0.967, which means that to find the angle at P, we'll have to find the sine inverse of 0.967, and that's equal to 75 to the nearest degree. Hence angle QPR is 75 degrees. So again, these are fairly simple 8 marks, as long as we remember that to measure bearings we always measure from our north line and we always go in a clockwise direction. Now these questions, more often than any other time, they always require you to use the cosine rule and the sine rule, but bear in mind that we can use these two rules to find both sides and angles. So it's important that we know how to use these rules to actually answer the questions that are being asked. Again, if there's any other questions, whether on bearings or any other topic for that matter, feel free to leave them in the comment section. I'll be more than willing to work the solutions to these problems. So until next time, continue to share, like, and if you haven't subscribed as yet, please subscribe. Take care and see you next time.